Thank you, Jesse. I really enjoyed the first session. I think this session is going to be equally riveting. My name's Ken Coley. I'm the Dean of Engineering at Western University, and apparently I'm sitting right next to Jesse's you just now. Maybe I should have chosen a different background this morning, but as I say, welcome. It is really a pleasure for me to introduce actually all three of the speakers in my session. Ishwar is Dean of Engineering at McMaster University. He currently leads the Pivot, which is an experiential learning program aimed at developing, I would say, developing thoughtful engineers who are future-proofed in terms of the curriculum, the kind of thing that Jesse was talking about earlier, where we are teaching students, or McMaster are teaching students to do stuff and learn while they're doing it, rather than rote learning of some sort of rather routine knowledge. I think it's an exciting initiative. I am really excited to hear what Ishwar has to say about this, and I'll hand you over to Ishwar.
I'm going to talk to you about unbundling the degrees, the lessons we've learned from the pandemic. While I'm going to make this presentation, there's a huge team that brought this to fruition, and a big shout out to Ken Coley, who worked on aspects of this before he moved to Western as well. So thank you very much, Ken. What do we mean by unbundling the degree? Well, first of all, let's talk about what engineering education is about. Engineering education is really about promoting active learning, which means that we have to have learners who learn by doing. And we feel at McMaster that the best way to do this is to do this through project-based learning and challenge-based learning, where our learners tackle real-life problems. They develop technical skills, but they also develop durable skills, soft skills, whatever you want to call it. And while doing all this, we emphasize peer-to-peer learning. So there's not only top-bottom learning, the sage on the stage. The sage on the stage becomes the guide by the side. There's peer-to-peer learning, and we infuse their learning with reflection so that students carry a portfolio with them where they can really see how their learning is progressing over time. So I'll give you an example of what we mean by that. This last September, we had about 1,100 engineering students come in. The pandemic was extant, and during their first year in their engineering courses, they had very few lectures. We sprinkled the lectures, but all 1,100 students essentially learned by doing, through project-based learning and challenge-based learning.
At McMaster Engineering, we're celebrating the launch of a new way to learn in the classroom as part of the Pivot, a transformed engineering curriculum, a reimagined approach to educating the whole engineer. Where does it start? Right from the beginning, with our new integrated Cornerstone design projects and engineering course. In addition to being an intro to foundational topics in engineering, this project-based course for all first-year students is an opportunity to design solutions to real-world problems in renewable energy, healthcare, and more. It was designed to thrive in a virtual setting, with teams collaborating through virtual labs and simulations using robotic technologies. This is made possible through our partnership with Quanser to replicate lab equipment in virtual form using digital twinning technology. About a dozen lab-based courses have been virtualized for fall 2020, with more upgrades to come. Our upper year students will also receive tailored experiences this year, from innovative lightboard technologies to virtual reality to lifelike experiments right from home. The result? Our students get the most advanced virtual labs found in any university worldwide. Design thinking, an innovation mindset, and entrepreneurialism is embedded in all programming. Students foster technical and soft skills in design studios instead of lecture halls. This is reimagined education at McMaster Engineering. This is the pivot. At McMaster Engineering.
So why are we doing this? We call this project the pivot, where we are changing our entire curriculum to project-based and challenge-based learning. And the reason why we're doing this is that we want to focus on 5 very important competencies for all learners who become engineers. The first is that they should be able to discover and create solutions. So discovery is very important. In that discovery, we integrate research with education. And research not just in labs, but researching problems and creating solutions. These learners should be able to integrate different disciplines and solve important problems. They should know that at the heart of any solution is a sustainable business case, and they should be innovators in merging their solution with the business case. We want them to have a very global perspective, but we also want them to know that diversity exists within their own communities. We want them to be citizens of the world, so the UN SDGs are part of our learning objectives and our ILOs, but we also want them to know that they are citizens of local communities, so that the UN SDGs should be applied to local communities. We've also started unbundling courses into micro-credentials. And we want to make these micro-credentials portable. We're part of the 12 University International Consortium that's led by MIT. We sit on the Leadership Council. There are 12 universities, and McMaster is one of them. We were the first university to give digital degrees to all of our learners 2 years ago. And engineering, in fact, rolled that out to the entire university, where students now carry their diplomas on their smartphones. And our previous version of this used blockchain technology, but we are using other trust platforms, rolling out next month and in November. At the heart of it is that students have a digital ID, which makes them anonymous. They essentially own their information. We respect the self-sovereign identity of students, and they can share that information with anyone in the world without having to go through a registrar or the Faculty of Engineering or McMaster University. And these credentials are digital. They can choose which credentials they want to share and which credentials they don't want to share. And we are going to be rolling this out to transcripts, rich transcripts, that instead of just having course title, will have some description of what the courses were and what the challenges were that the students overcame and what their competencies are. All this is leading us to an effort called McMaster Access. McMaster Access is about unbundling the degree and educating anyone, anywhere, anytime in the world. It's a series of stackable micro-credentials for in-demand engineering topics. And so essentially, it becomes an accessible, inclusive, and agile path to a true McMaster engineering education. We will take in-demand contemporary topics in engineering to enrich learners' learning, to accelerate their learning, or transform their careers. So we will have students who will be traditional students in degree programs, but we'll unbundle those degree programs so that they can be accessed by learners anywhere, anytime in the world. These will be agile programs, modular programs with groundbreaking pedagogy and technology, such as the one that I showed you earlier. And we hope to roll out our first version this coming fall term. Now, let's talk a little bit about international collaborations. I wrote a paper a few years ago about how dual degree programs were very beneficial for students. They were beneficial not because they gave students special technical competencies, but they gave them an understanding of relativistic ethics. They gave them an understanding of independence, how to deal with different people. And what the pandemic has shown us is that we can scale up based on virtual technologies, this sort of international collaboration. And I'm going to give you an example. The example is Global Studio. Global Studio is an international learning experience which uses human-centered design as its basis. It involves 7 universities on 5 continents. It started as an initiative of the American Society of Engineering Education, and they asked me to bring an international audience together. And these 7 universities stuck it out. We spent 2 years talking about this, and then right now they're building the template for Global Studio. And Global Studio has Monash, Elizabeth Croft was here, Mac, Jim Nicel is going to speak to you later from McGill. It has UCL, Emanuela and John Mitchell are here from UCL. So many of these actors are here before you today. What exactly is Global Studio? Global Studio, in our vision at McMaster, and how we hope to enrich it, and the different universities are going to enrich it in different ways. But our enrichment is based on our flagship program called Mac Changes, where we amplify experiential learning outside the classroom. So what we hope is that our students will work with students from other universities in interdisciplinary teams on projects that will align more or less with one of the UN Sustainable Development Goals. I'll give you examples of previous Mac Changes projects. They were projects to reduce emergency wait time accessibility, reduce paper receipts in local businesses in Hamilton. So the students are thinking globally, but they are acting locally. So that's our vision for Global Studio, and it's going to be really exciting to have these students work together this coming in late summer, early fall, in order to tackle projects across these time zones, just as we are doing today. So these students are also going to get micro-credentials. They'll have digital IDs. They can port their micro-credentials to just about anybody. They can post them on LinkedIn. But essentially, we are moving away from the tyranny of the transcript, which basically tells you whether somebody's completed some arbitrary sequence of courses within and outside of engineering. And students will be able to stack their competencies and show them to employers. Or we'll start with learners first, and then we'll come to students when this becomes prevalent. So essentially, what the pandemic has taught us is that we can educate anyone, anywhere, anytime. And I think that the future is going to be really, really exciting. Thanks, Ken.
Thank you, Ishwar. Our next speaker, Jane Goodyear, who is Dean of Lassonde School of Engineering at York University. Jane is a British New Zealand engineer and academic. Prior to appointment as Dean and Professor at York, Jane served as Head of School of Engineering and Advanced Technology at Massey University. From her personal experience, Jane knows that education can transform lives. She is a first-generation learner who has benefited from post-secondary studies and is passionate about opening doors and provided opportunities to other first-generation learners, especially from underserved communities. Jane has always sought to bring academia and industry closer together and has now brought her expertise to Canada. Another talk that I'm really looking forward to. Over to you, Jane.
Thank you. Hello, everyone. It's an absolute pleasure to be here with you. And I'm very much looking forward to sharing my perspective on this pandemic and where we should be going. But I'm also really pleased to be learning a lot from my peers. So it's a win-win. Anyway, firstly, let me introduce you to York University and the Lassonde School of Engineering. For those of you who don't know, York University is the third largest university in Canada, and we have approximately 55,000 students, so we're quite large. Our school has a strong heritage in computer science that is actually weaved in amongst our engineering and earth and space sciences, so we're quite a collective of expertise and so forth. So we in the school have a very broad demographic of students, our students live within a commutable distance and having direct, easy access to public transit. Hence, 90% of our students commute, 70% of our students work part-time, and nearly half are first-generation learners. And as a school, I would say The demographics are quite typical of engineering school challenges, attracting women, Black and Indigenous students. Now, my talk today is very much exploring some of the challenges our students had prior to the pandemic and finally presenting a future that alleviates the challenges and make our programmes more accessible. So firstly, let me just look at how COVID has impacted youth from low income and racialised communities. Black community members, parents and students have long protested the inequities that have contributed to the social and educational conditions in which they find themselves. Today, COVID-19 has added yet another layer of complexity to their problems. In fact, the pandemic has not only added to the social and educational inequities amongst young people, it has exacerbated the racial injustice which we must contend with. My colleague at York University, Professor Carl James, in his recent article on racial inequality, COVID-19, and the education of Black and other marginalised students, he actually outlines a circumstance which I think we need to just have a think about. It's a mother with 2 children, and to quote, "Remote learning in the spring was manageable for her 17-year-old son, but a nightmare for her 8-year-old daughter, who she tried to keep on track whilst working. Poor internet connections, late night prepping for the next day lesson plans caused the parent to actually discontinue her daughter's schooling." We as engineering educators have historically had to contend with significant underrepresentation of women, Black and Indigenous youth. The impact COVID will have on the pipeline of youth entering our programmes will be significant. Let's talk about our learners that are having to pay for their education or having to have long commutes or even caring responsibilities. This in turn significantly reduces the opportunities for them to fully engage in their studies and broader learning possibilities such as clubs, study groups, networking. And if we take a look at the impact of the commute, for instance, I mean, this was a survey very recently of 18,000 students across the GTA of Toronto, which takes in universities such as mine. 30% commute for more than 2 hours. 41 commute times discouraged class attendance. The cost is outrageous. And most commute really shortens the time that they really do spend time on campus. And 60% blame commute for disengagement of campus activities and events. And basically, it is a barrier to co-curricular experience. What about working part-time? The quality of their work experience obviously doesn't prepare them to get good jobs after graduation. 50% in this study of students are working more than 15 hours a week, and that has an impact on the grades they get. And again, the impact of having to do less chance of doing co-curricular and extracurricular activities. So these are the challenges prior to COVID. So the future for many of these students will be quite uncertain. So let's talk about our pivotal moment. However, we now have a window of opportunity to keep these pedagogical innovations and help build momentum that allows for more flexibility and accessibility for these kinds of learners. And truly, we have an opportunity to build programs that are much more inclusive. What I'm just trying to portray here is, like many engineering schools across the globe, we, due to COVID, have pivoted. We've reimagined our digital learning methods. We now have flexible, integrated, exceptional online and hybrid teaching modalities, from the live classroom, live hybrid classroom, online, asynchronous online. And for just my school alone, we've been completely online for nearly 18 months. With this technology, we've had over 5,000 hours of video recordings created of labs and all sorts of lectures. The videos themselves have been viewed over 350,000 times. We have 4,000 plus users, and over 350,000 have been engaged in various activities. And that's just our school. If you think about what we've been doing globally, it's amazing what we've done. So, whilst COVID has been a challenging time for all, it's also been an opportunity to take stock about how we utilise our learning and apply it to our outreach initiatives and programmes. How can we help our youth, especially those who are traditionally underserved, get them a step up on that's solely needed? So, again, many engineering schools like myself, we have a lot of outreach activities. And at Le Sonde, we call our programming called the K2I Academy. And we're actually trying to work quite differently to dismantle systemic barriers. And I won't go too much more into that detail, and you can get in touch with me to find more about how we do that. But prior to COVID, we held many outreach programs, and I've just got a couple there from the Ontario's Women in Engineering's Go End Girl program, where usually we get around 100 girls and their parents coming for the day to engage with hands-on activities. Or we've been supporting First Robotics Canada, bringing in 1,000 students to compete. Now, we've learned quickly to pivot and still manage to provide some level of support specifically focusing on underserved youth. This learning has allowed us to rethink and rescale. We're now focused on supporting teachers who are working in schools with low educational outcomes, to provide them with resources and professional development to help them bring STEM subject to life in the curriculum. And for instance, we now, with the technology we've got, we're piloting a program to empower 375 teachers to deliver curriculum in underserved priority schools for over 11,000 youth. Now we've got the technology and the capability. Around me, I've now got the capability to help 400,000 high school students. It's amazing. So what can we do for our current students in our programs? Now, I'm just going to give you a snippet of some of the innovations. This one is our capstone project. And in fact, this has been a collaboration between one of our aerospace engineers partnering with a colleague from the Department of Dance. And this is an extension of the engineering capstone that includes all faculties at York University and also globally. And in fact, we grew from a pilot about 2 years ago from 50 students to now 160 students. And in fact, we won the, happy to say, the 2020 Global Engineering Deans Council Airbus Global Engineering Diversity Challenge Award. So I'm very proud about this project. But the thing is that in now a virtual world, we've expanded our scope. We've brought together students from theatre, kinesiology, anthropology, politics, to work on projects such as, developing an inflatable solar energy for developing areas and remote communities. So we've now widened the field to work with multiple partners. And don't you think we should pat ourselves on the back that we can still deliver on projects connecting multiple people from across the world in a virtual space? We really don't want to lose this. So if we take a look at some of our individual courses, I've had faculty and staff who have taken a land surveying field course in civil engineering and completely flipped the class, adding a virtual lab space using gamification and virtual reality. it's incredible what we can do. And this is only one example. I've got many, and we're showing as many as we can today. But we now have opportunities to bring the lab to the student anytime, anywhere. Now, don't get me wrong. I believe we need students to have physical hands-on learning, but we also now have an opportunity to provide more experimental experience in both the virtual and physical platforms. We also have an opportunity to reach out to our students and community in a much more open way through conducting virtual fairs. And in fact, we've created a number of successful virtual events, such as an undergraduate research virtual conference, careers fairs, student club fairs, and recruitment fairs. For instance, our Lassonde Undergraduate Summer Student Research Conference, we showcased the research of 60 students. We had, at that virtual conference, 200 registrations from students, staff, faculty, and external guests. We could also offer internal booths like co-op and the grad student, come and join us for grad school. It was awesome. We've also had our civil engineers student club have an industry network night where students and industry came together to network and form relationships. And we've also had our capstone day, which again brought together 56 teams. We had over 600 registrations and 22,000 page visits from that. So it's awesome what we can do. So coming back to why I'm talking about all this, we've got an opportunity to level the playing field here. So how do we exploit what we've been doing in a virtual world to help alleviate some of the challenges faced by our low income and racialized youth, our commuters, our caregivers? Remember these challenges: school children who need to catch up, commutes of more than 2 hours a day with a tightly scheduled time, high levels of disengagement in the campus, activities, events, co-curricular experiences, and basically trying to fit academic work around part-time work or caregiving. How can we change the status quo? This is a snippet from Reddit, a Reddit post asking about their first year timetable. Notice this assumes that a student is on campus 9 to 5 every day with spaced out learning so that they all engage in co-curricular activities. Does this really cater for the students I've just been talking about? What could a timetable look like that shows the future? Would there be no lectures as they've all gone online? Would there be a day just for drop-in labs where students can go to tinker and get confidence as they've been through the labs virtually prior to taking a competency assessment? Would there be a set time for face-to-face group meetings to support their virtual project work? Could there be a virtual fair, block of time where various events, conferences, industry talks are held that can be seen live or asynchronously? Remember, the future learner wants to spend less time commuting, wants to earn while studying, wants to learn at their own time and pace, and wants a future-proof academic programs. As engineering educators, do we now have a window of opportunity to keep these pedagogical innovations and build momentum that allows for more flexibility and accessibility for learners? Thank you very much. And that's the talk for me.
Thank you, Jane. I think that was at least as billed, very stimulating, and I've got lots of questions for you later. I think next up is Jim Nicell. Jim is Dean of Engineering at McGill University. Jim joined McGill's Department of Civil Engineering as a professor in 1992 and has served as Dean of the Faculty of Engineering since 2013. He's an environmental engineer who specializes in applied green chemistry, pollution control, and impact assessment. From 2007 to 2012, he was an Associate Vice Principal, University Services at McGill, with responsibility for campus planning, construction, infrastructure, and building operations, as well as safety and business units. He has been a registered professional engineer since 1991 and is a fellow of the Canadian Academy of Engineering. From 2019 to 2021, he served as chair of Engineering Deans Canada, comprised of deans from across Canada.
Thank you. Hopefully you can hear me and the presentation is now visible to everybody. I have to admit, it's a little daunting to follow on all the other speakers because I heard a lot of answers and I think I'm going to raise a lot of questions today, hopefully not wasting your time. But I will go back to something that I've learned over the course of my time at McGill and in my many positions that I've had, which is that every crisis I see is an opportunity. It's a chance for people to actually take a look at what's happening around them, what's going wrong, what's going right, and to learn from that to actually improve things for the future. And I would argue that the pandemic over the past more than a year has actually been an incredible opportunity for us to look again at engineering education and again, see what goes right, what goes wrong, and then learn from that to improve going forward. Hang on. So I'm just going to present this very quick disclaimer, which is for the purpose of this presentation, I interviewed quite a few professors and looked back on our experiences that we shared over the course of the past year. I will never call this data. These are a series of anecdotes that have resulted in a series of experiences I'm going to share with you today. But I don't think that this can be represented as a true study. So this is anecdotal only, but I think that there's a need to look more deeply into a lot of the issues that I will describe to you. So first of all, without going into any great detail, how did we adapt to the realities of COVID in the past year? Well, there are numerous ways that we did this, but I'll just give you some primary examples from my own personal experience and what we did. So we obviously shifted to remote learning for lectures, tutorials, and labs. Many students, because of their personal situations, decided that they would move away from the campus where they are, often internationally, went all the way around the world. We lost about 30% of our students outside the country over the course of the first few months of the pandemic. Very interestingly, there was universal and widespread adoption of tools that had rarely been used before, including Zoom, MS Teams, and innumerable other platforms. So it meant that not only did we adapt, but the larger population out there has adapted, and they're primed and ready to use these tools right away. Flipped classroom experiences became very, very common just as people tried to adjust to the realities of COVID. Where actually what people were doing is they were introducing the knowledge download, if you wish, that was happening typically in lectures to something that happened outside the classroom where people would actually watch lectures and then come into the classroom for a more guided learning experience under the supervision of a professor. We also saw the use of lab kits where students were sent laboratory kits where they would do it at home, use these kits at home to conduct their own experiments, or in many cases, without lab kits, they were actually constructing new experiments and reporting on the results of their work in the classroom. Coupled with this was remote access to software and equipment on campus, which meant that people are actually able to use these tools more broadly over the course of the 24-hour period of a day. Remote assessment became the norm of the day as well, including a shift to non-time limited exams, often because of the issue with time zone issues. We had a move, I think, more broadly because of the nature of cheating and the like. Go back here. A move toward open-ended questions, but also a move toward lower stakes, more frequent assessments, which everybody said was a good idea at the front, just because having these major 3-hour exams to be your whole form of assessment was deemed to be inappropriate from a pedagogical point of view. And so there was a sense here that we would have more frequent but lower grade exams. We also expanded the use of pass-fail, satisfactory, unsatisfactory options, whatever it may be, in trying to adjust to the reality of COVID, which had different impacts on different students. When things loosened up to some degree, we reestablished some in-person activities wherever possible. But very often it was done on a temporary basis because as COVID reclosed back in, we had to put some of them on hiatus. But also in many cases voluntary for those students who happen to be local and would have the opportunity to come in. And the result ultimately was an experience with hybrid classes, tutorials, and labs. We also moved very extensively to remote advising, counseling, and mentoring, enabling more one-on-one interaction with people wherever they were in the world. And we also, unfortunately, had to eliminate many in-person extracurricular activities, and those included social and competitive or design team type activities, which are very common to our students and highly valued. And I'll just say on a very, very important point, individuals within institutions, units within institutions, and then institutions themselves began to collaborate with each other to try to figure their way through the difficulties of the pandemic. Well, this adaptation obviously was happening very, very quickly, and it resulted in a number of unforeseen problems that maybe some of them more foreseen than others. But it was really important that we learn from what went wrong. So first of all, as was just mentioned by Jane in her presentation, the issue of the unequal or inconsistent access, perhaps due to the different socioeconomic status of our students, meant that they were not necessarily all getting equal access to the courses. This is further complicated by issues of time zones. And then we became very, very aware of the family care responsibilities that many of our students had, either directly, personally, or sometimes to raise an income to support their families going through very difficult periods because of the COVID. Privacy issues became rampant. The issue of camera hesitancy, where students felt that they did not want to have our professors and other students entering into their homes. And of course, many universities that started using exam proctoring software also raised innumerable examples of privacy that people expressed great concerns over. Workload was a massive problem. And I think even with the best of intentions, what often happened is that the professors would upload all of their lectures, asking our students to actually run through all their lectures, and then they would use the full schedule time to support them in their learning. But the process of doing this, they may have individually have increased the attention they were giving our students, but he inadvertently, when this was happening across multiple courses, created massive pressure on the time and the schedule of the students themselves. This also created major problems when it came to the frequent assessments at more frequent but lower grade values, where we found our students who were heavily grades oriented, often very competitive with each other, did all that they could with the non-time limited exams to spend more time in the exam to eke that last little bit of grade out of their courses. And so they compounded their own problems with respect to times and scheduling just through their own competitive behavior. Obviously, screen workload, including screen overload, including working, studying, socialize, and entertainment, all on screen, led to what many of us would refer to as Zoom burnout. Mental health issues, of course, being a major consequence of that, was burnout, distraction, demotivation, and disengagement of people from the classroom, from each other. Work-life balance was disrupted with longer days, often replacing longer commutes with more work time, or the intrusion of our work and our studies into more aspects of our personal lives outside of the normal working day. And this led ultimately to poor compartmentalization between all the different facets of our work, which actually meant people didn't have the appropriate downtime. And finally, the really, I think, a consequence of all that was reduced social interactions and physical exercise as well. Cheating, we've had multiple reports, in fact, massive explosion in the number of allegations of cheating on the part of our students, particularly during assessments. I would say it's very real, but it's also perceived, and often I would argue obsessively. People were almost in an arms race to figure out how to prevent students from cheating, and they were just trying to replicate under tighter and tighter constraint conditions the typical form of assessments, and actually made the situation even more difficult from a mental health perspective, pressure perspective on our students. Another key part was grade inflation, the massive grade inflation that we saw over the course of the first term that we had completely under remote conditions, which you could argue may not be a problem at all. But I saw come from that was an obsession between students and professors about the grades, trying to max or eke the most they could out of this period of high grades to improve their prospects on their transcripts. But it also confused other issues with respect to awards. It confused the issue of admissions, both to graduate school, but also from students who are actually coming into university for the first time, and complicated standing decisions on regarding the satisfactory progress of our students. There's also a dramatic shift on summative rather than formative assessment, creating a kind of an arms race increase in course intensity or difficulty. In other words, as the grades went up, some of the professors reacted to this by making much harder assessments, more rigorous courses, more intense, to try to bring the average of the grades down. And finally, ghosting by students and professors means that the students and the professors actually disappeared from the courses themselves. Sometimes the professors were not actually there. In fact, there's one instance of one university here in Canada where a professor had passed away and the entire course had run before any students actually knew that the professor had passed away, because it was all done online and virtually. What went right? Well, I'd say democratization of the classroom, essentially this idea that now everybody's in the front row and you could have more direct interaction with all of the students in your course. This collaboration that happened between individuals, units, and institutions. Experimentation in new techniques of teaching, where professors who were more avant-garde in their approaches started to instruct and support others, with some experience in blended learning. We saw new people and places brought into the classroom, where instead of inviting a lecturer into your classroom, somebody who may be down the street from you in your university, we are bringing in key leadership in certain disciplines from around the world and bringing them into the class and bringing a degree of exposure that was never seen before. We saw less lecturing with much more active interaction enabled through tools such as whiteboards. So for example, in one of my schools, at the School of Architecture, where we had leading architects actually annotating the work of the students in front of other students, and it led to phenomenal interaction between the experts in the field and these students. We saw personalization and independence of learning, including the home labs that people conducted. We saw a shift to open-ended or formative assessments, where people started to realize that there were better ways to form assessment or to do the assessments of our students, including moving to more project-based learning and assessment. We saw a wider variety of student team experiences, where different teams were formed that would never have been formed before, where you could reorganize very easily, more easily than you could do in a classroom. You could reorganize teams on a day-by-day basis in your classroom. We saw physical limitations on class sizes reduced, which was really interesting, because we saw a shift in more students going into certain courses that were in high demand and then dropping away from courses that were in low demand. And it actually has raised real questions for us about which courses we should continue to offer at what size. We saw a shared sense of purpose between everybody involved in the current situation. So again, that's the crisis that created this opportunity. And finally, an appreciation, I think, a growing appreciation of the human circumstances of professors and students. So we saw those cases where students would witness a professor who had one or two children in the background, or sometimes nursing right there in front of them. And it was a very, very interesting experience that humanized the professor, and of course the professors witnessing more what the students were going through. I'll go on now just to say the good, the bad, and the ugly that came out of this. Well, the good is, and I won't go through all this, but there's so many questions that came out of this. But we've already started to address the questions about what new capabilities we developed that could use to enhance the educational experience. But now, because of the workload issues that we created, we started to ask the question, how can we best use the time the students have, not just within the scheduled time, but outside the class time over the course of the full day? How can we better equip students with the new tools that are actually entering in their educational process, that are actually tools that are being taken up in the business world as well? And so this is an opportunity for them to develop more. The important questions Jane asked about how can we make engineering education more inclusive, equitable, and diverse? I'll drop down some more other issues here, but well, how can remote instruction enable educational experiences that were formerly out of reach? So the idea of bringing a place where a student is somewhere else in the world into the classroom, so the student could actually share the local context, the local culture with their colleagues. Really important questions about what is assessment for and how can it best be achieved. Real questions here about, are we focusing too much on grades just to rank our students, or actually we focus on competencies? What are the hands-on and project-based learning experiences for, and how can we make best use of them? So in this case, I noticed, for example, the move toward the home approach to these laboratories led to a more creative process rather than a kind of running through a laboratory as a recipe that is to be followed. A key issue for us is how can we better engage with our partners, including other disciplines, institutions, industry, and the broader communities, to improve our educational experiences? How can we enhance the out-of-class experience to better prepare our students? Or how can we better prepare students to be independent masters of their own learning? There was a high degree of independence requested of our students over the past year. And the question is, how can we better use that and make it part of what we're doing? How can we effectively bring the world into our classroom and other teaching activities? How can we adapt the realities of accreditation to deal with the modern reality and these new tools of engineering education that are going to push the balance on what education actually looks like and may not be recognizable to many accreditation bodies? And of course, how can we balance the workload of our students to safeguard mental health and ensure better learning? It goes on and on and on. There's an endless series of questions. But I would argue the biggest problem that we've got right now is the ugliness, the things that are systemic barriers to actually change. I won't go through them all here, but I will say there are certain things that we need to change in our respective roles within a university to unleash the potential of all that we've learned over the past year. This includes things like performance criteria for our professors for tenure and promotion, including over-reliance on questionable metrics, but actually moving toward recognizing more fully people's contributions to engineering education and its advancement. The research-intensive cultures itself really force our professors, I think, to think less about what teaching should look like. The lack of funding for engineering education research to actually make sure that the work that we are actually doing, the way we are adapting, actually is effective. Or looking at the disciplinary and organizational silos, both inside and between institutions, that prevent us from collaborating and are often complicated by issues of competition, public relations, and things like that. The slowness of accreditation systems to adapt, and which have a tendency to ratchet upward in terms of their scope and the demand on our educational systems. The internal systems themselves, organizational structures, budgetary, cost accounting, or even infrastructure that represent a barrier from actually for us exploiting the new potential that we have. So for example, if I wanted to send my students to McMaster University to take advantage of the Pivot program and some unique courses they have, there are all kinds of people in my own university who would block me from doing that, showing us the budgetary implications of sending our students to another university to take advantage of what they have to offer. Or an overemphasis, finally, on grades as academic currency. And this issue of grade inflation, which made people all concerned about how do we assess people for scholarships, admissions, and then even employers who don't know how to deal with transcripts, where often HR departments of large industries use the GPA of a student to actually create a short list of people who they would move to an interview stage. And I would finally say that we've got all these traditional practices of instruction that remain, the chalk and talk approach, the approaches to assessment that we've used, which we tried to replicate online, the approaches to labs, the approaches to grading, and of course, shifting people away from those traditional practices is very difficult. And then finally, the last 2 points, constant pressure, and I would argue that this is often self-induced to expand the program content. We've witnessed now the increase in work on our students, but what we've really realized is that often what it is that more and more professors want to inject the knowledge that they have, the experience they have, into the heads of our students, not recognizing that they're overwhelming the students with content, with experience, and they're actually undermining their learning. And finally, I would argue that the biggest problem that we all have is that we are, as individuals, resistant to change, working within a very complex system that discourages risk, and this is all compounded by a tendency to return to what is comfortable and familiar. I'm very concerned, of course, about what happened over the pandemic, but this is too good an opportunity for us to not take advantage of. And I'm very worried that as we return back to normal conditions in the very near future, we will just return to our patterns of doing things the way we used to do them. And so I'll just end with this last little slide of a very famous cartoon from years ago. I'm probably showing my age, which is, we have met the enemy and he is us. That is, we are probably the very people who will get in the way of taking advantage of all the great things that we've learned over this past year. Thanks very much.
Thank you, Jim. We now have an opportunity to go to our panel. And I have to say I've been trying to follow the question and answers all the time. I was also trying to listen to Ishwar, Jane, and Jim. And there's been a lot of rich discussion. I think a lot of the questions have been answered, but there's been a few themes have emerged, and my apologies if I combine questions, because I think that's the only way we'll get through things. But if I can start with the sort of the pivot type concept and the project-based learning nature of something like the pivot, and it may not be the pivot, it may well be another version of a similar thing. One of the the questions that came out, and it came out more than once in different ways, was how do you ensure it's clear how something like the pivot works for the project-based skills and taking on a major project and solving it, but how do you address the need for some foundational learning? I mean, even those of us who lean to my kind of philosophy, where we prefer to not overstress knowledge, some knowledge is necessary and some basic skills are very definitely necessary. How do we ensure that happens with something like the pivot? And I'll let Ishwar kick this off, but I think this is a question that's relevant to the rest of the panel as well.
Thanks, Ken. So my answer would be the same as yours, because we've been talking about this now for almost 8 years. And although you're at another institution, we still have these discussions. So I think the answer that you would also agree with, Ken, is that very often in engineering education, we become fundamentalists. It's my way or the highway. We start grasping at orthodoxies. Project-based learning or challenge-based learning is the way to go. And the other person will say, well, no, the lecture-based learning is the way to go. I would say that we in the 21st century are very fortunate to have been exposed to many, many different pedagogies, ways of learning and teaching. And there are established approaches like Bruner's spiral curriculum approach, using Bloom's taxonomy and so on, where we can blend the different pedagogies. I think that as we move away from project-based learning, as we move towards project-based learning or challenge-based learning, it doesn't mean we throw all the old stuff out of the window. There has to be a blend. The fact of the matter is that in some courses, students get bored. You start out with about 70 or 80% attendance, and then it drops to about 20, 25% attendance before there's a review session, and then it spikes to 95%. So students are actually voting with their feet. And so I think that if you analyze all that, you use this blend of pedagogies to do what is best for learners. And the pandemic has certainly opened up several possibilities because of what we've been able to do.
Thank you, Ishwar. Jane?
I'd like to add on to what Ishwar's saying, particularly about the pivot and project-based learning. And there's a lot of curriculum that are now having project-based spines as their core around how we create our engineers of the future. I would argue that now we have the technologies to do some really awesome stuff to generate and bring like the fundamental physics to life and mathematics and things like that. We now, through the things like the pivot and the project-based spine, we can pull that learning rather than push the learning to our students on these fundamentals where they're thinking, well, why am I doing this? Why am I having to do such structural equational modeling? I have no idea. But when you put them in context and pull that learning, it's a much more powerful prospect.
Thank you, Jane. I agree very strongly with that point. Jim?
There's not much to add to this, but I will say that often there's false dichotomies. People argue about which way is the best. It's either this way or this way, and they get into their ideological camps, and they can't seem to kind of bridge the divide. I would argue that every student is in itself, himself or herself, a very different person with very different styles of learning. And I actually think that we owe it to our students to not adopt a singular approach, but to have a diversity of approaches that connect more broadly with a diversity of students. So people need to see themselves in the educational experience that they have. And some experiences will work very well for some and less so with others. So I would never argue for one approach is the best way to go versus the other. The diversity of experiences that develop with the students themselves is really the way to go.
So can I add, I'll add something just very briefly. It's something that I learned at the feet of Ken Coley is, I didn't know what integrated learning was 8 years ago. And Ken was my big educator. And integrated learning means that you don't have to have a 3-credit course in one thing and a 3-credit course in another thing. You can actually merge those courses so that the students, as Jane said, learn math, they apply it to structural equations or fluid dynamics or whatever it is. They learn Maxwell's equations and apply it to something. And so integrating different subjects, through a blend of these pedagogies is, it's a way to go. So I think that's what all of us are trying to say.
And Ishwar, given that you plugged me, I just have to interfere in this conversation. I can't help myself. I think one of the great powers of project-based learning in general, and in particular integrated learning, is the students develop confidence in building their own learning. And that's how you future-proof the curriculum. We can never future-proof the curriculum by looking in a crystal ball. No matter how good our crystal ball is, it only predicts a little bit of the future. And we can't keep changing the curriculum. So if we teach the students to change it for themselves, that's really, to me, the power of project-based learning. But I have another question, really, that ties into something Jim said at the end there about a blend of pedagogies. The part of the problem with if you have a really broad blend of pedagogies, and I completely buy into the concept of it, but if you have this broad blend of pedagogies, you're going to need a lot of assessment, and I'm thinking probably lots of low stakes assessment. So you made a point about low stakes assessment. How I know that there's a lot of advocates for it in the pedagogy, in the world of pedagogical experts. But I'm wondering about your experience. Did you find that a lot of low stakes assessments drove better learning?
Personally, I don't think so. I think that as much as our pedagogical experts at our university said that this was the way to go, it almost became a treadmill of focus on assessment as opposed to learning. So maybe if we can somehow go to low stakes, more frequent assessments that's formative, so that the actual exercise of assessment in itself is a learning experience. So I have one colleague who started doing assessments where he'd have students actually work independently, and then for the second half of the assessment period, they would work as a team. And they would actually use the experience itself to learn from each other. So when you can start to do those sorts of things, it's less about creating barriers for students to prove how good they are and actually about supporting them in their learning. Then it's a very different approach. But right now, I think what we did is we did it all wrong. It became about absorbing students more, even if these were low stakes. I'll say for my own students who are phenomenally competitive students, they want everything they can to get out that grade to differentiate themselves from all their other colleagues when the day they graduate. In the process of doing that, they lost sight of the learning and were only focusing on earning these grades.
Okay. So I saw Jane with a very positive thumbs up as you were speaking there, Jim. It occurred to me that perhaps one of the problems we had with the move to low stakes, well, actually, I think there were two problems. One was that we did the same thing that we've always done. We just did it more times. And the other is that I think as a group, academics have become much more focused on the importance of assessing than the importance of learning. And I think we've kind of lost our way in that. And Jane, given your enthusiasm for the things that Jim said, I don't know if you want to jump in there.
Yeah, all I can say is that through personal experience, I stopped doing examinations probably 15 years ago. I even stopped doing lectures, and what I found was, and the assessment piece is really, really tricky. If you create a piece of assessment that really encompasses critical thinking, and then you scaffold the learning towards that goal of a key assessment, then that.
Oh, I'm afraid we've just lost Jane. She suggested this might happen, and I think that we were really building up to the punchline there. I hope she can put it in the chat for us, and I wonder if somebody can ask her to. But I'd like to just keep things moving, and we can come back to that. So another question was about micro-credentials, and there was two core questions I think asked about micro-credentials. One was it's very good for key and current, up to the minute kind of knowledge delivery. But how do you do it? How do you use it to develop some of the core competencies? And the other part that came up was if you build your curriculum around micro-credentials, how does that help you in terms of, or does it not give you problems in terms of the complexity of your curriculum, I think was the question. And I'm actually, I know Ishwar's anticipating this one, but I'm going to ask Jim to kick it off.
Oh. Sorry, I'm back. I got thrown out.
No, I'm going to ask Ishwar to kick this one off. I was just reading one of the questions here. I was trying to.
All right, so Ishwar.
All right, so I think that again, we get hung up on nomenclature. There've been badges around, there've been micro-credentials around. We say, no, micro-credentials are for these topical things. They're industry oriented. I mean, think about a micro-credential as being a small credential. I mean, after all, the diploma and the degree is a credential. Our universities give certificates. Those are credentials. A micro-credential is essentially a small credential. The way I see micro-credentials are that you've satisfied certain intended learning outcomes or ILOs, right? And you've gained some competencies. And those competencies are such as the competencies of the pivot. You can discover information, create solutions, integrate disciplines, whatever the competency is and whatever the ILOs are. I think that there is a space for private sector employability-based micro-credentials, but those are the micro-credentials du jour. AI is hot today, so we're going to give AI micro-credentials for learners who already have degrees and so on. But maybe the AI micro-credential won't be the micro-credential du jour in like 10 years. It might be a decarbonization micro-credential, right? So those are separate, and those are very immediate micro-credentials that you have to keep pivoting from one topic to another topic. The others are the kind of credentials we give through our degrees. I mean, I actually don't agree with Jesse's opening remarks that engineering education hasn't changed much over decades or centuries and so on. It has. I mean, our pedagogies are different, our ILOs are different. And so what I actually think is that we can take our pedagogies, our degree programs, and start unbundling them. And when we do that, that's another class of micro-credentials that provide access to learners anywhere in the world. Now, if somebody wants a Western education today in Malaysia, it's very difficult for them, it's very expensive. But once you start unbundling that Western education or the York or the McGill education, these learners can get a slice of that. And imagine a future where we all collaborate and they get slices from all of us. Think of Netflix. There's drama, there's romantic comedy, there's something. So they choose from those tranches of horror, romantic comedy, drama, and somehow it all makes sense and you can stack them and maybe they get a degree over time, at their own pace.
So Jane, how does this help the access that you're really pushing for?
Sorry, Ken, I'm really having trouble. You're going to...
Okay, I'll assume that it does because I actually think it does.
I'm so sorry. I'm really having.
I'll go to Jim because actually another question came in the chat that I think sort of opens up the whole micro-credential conversation. I mean, one of the points that was made is that during the pandemic, this continuous, and actually, Jim, you made it fairly strongly on behalf of both faculty and students, was this sort of continuous treadmill we seem to be on, just lots and lots of Zoom time, long days, no boundaries on when the education piece started and stopped. And there's a question in the chat that actually Ishwar answered, but I think it's an insightful question and it fits into what we might do with micro-credentials. And the question is, why do we stay with the semester structure? Online learning is very intensive. So what about changing a stream into several terms with a focus on max 2 subjects per term? Or maybe several micro-credentials per term, but Jim.
I honestly, I don't know whether that's good or not. I mean, from my point of view, is a learning experience better if it's more intensely focused on a few subjects than on a wider variety of subjects? I recognize myself when I've gone through these semesters in grad school in particular, where you took a couple of really, really intense courses that were offered over a shorter period of time, but you forgot about all these other things that you were working on. So it seemed that I got really deep into those subjects, but I almost feel like I had to reset my brain to then tackle the next set of subjects. So I just think there's an issue of also spreading learning over time, which is a combination of introducing, reintroducing, reinforcing, integrating over a period of time as to going down to the compartmentalization. I do agree that we need to take a close look at this semester approach. I mean, I think we've got an approach that is really built around, farmsteads and other things like that, growing seasons, and we really need to take a look at the full life cycle of a student over the course of a year and see how to better use that time. I'm not sure what the right answer is though at this point.
No, and I think it's something we're all wrestling with. I mean, as Ishwar kind of outed me as a strong proponent of integrated learning, and this sort of very intense package kind of defeats that. I think what you lose with that approach is probably context, and I think engineering is something that works really well in context. So, I guess there are pros and cons. I think, well, actually, I've been told by my boss that I have to draw this to a conclusion, but I could do this all day. I think this has been a great conversation. I hope we will have many more online and offline. So thank you, everybody.